And here's my first one. Alkynes, same rules as alkenes. An alkyne has a triple bond instead of a double bond. However, there is no cis or trans when there's a triple bond, because if you have carbon triple bond to carbon, that means that that carbon only has one bond left. So there's no above or below. So even if you did do it in line angle with zigzags, it's not actually zigzag at that point. When you triple bond, you're sp hybridized. You're linear because you only have two bonding orbitals to go to. I'm not familiar with multiple triple bonds within one molecule. So you remember last time if you had two double bonds, it was a diene. I don't know of anything that has two triple bonds for like a diene, so I wouldn't even worry about that. Okay, this is my last slide. I guess I have answers on the next one, but I could just say the answers as well. Why don't you take a minute to see if you can name these two things. Keep in mind that right up here, I did not continue the triple bond all the way across for a reason. So in other words, there's a carbon right here. Okay? So again, reminder of what we're doing is we have to find the longest carbon chain. That's step one. And that should contain the double bond or the triple bond, depending upon what type of thing we're looking at. These are triple bonds, obviously. Then what subgroups are coming off of it, and where are they coming off of them? This is the next thing I mentioned. Remember, our numbering system gives the double or the triple bond the lowest possible number. So if we're not always reading left to right, we could be reading right to left, top to bottom, however silly that molecule might be drawn. And if it weren't up to those double and triple bonds, it would be up to the subgroups coming off of it to have the lowest possible number. So let's give you about 30 more seconds, and then I will show you the two answers, and that's where we wrap this up. So looking back on this, I do have a slide on cycloalkanes, but we went over that on the day I was gone. Remember rings? Could just easily be a cycloalkene. I'm not aware of typically things that are cycloalkynes. So I'll show you one more thing instead. Okay? Now, the first one would be called propyne. Prop for 3 carbons. Again, I tried to indicate that there was one in the middle there. Yne, because there's a triple bond. This gets back to Claire's question a minute ago of labeling. Some of us might have labeled it 1-propyne because the triple bond started on the first carbon. And I see why that makes sense. The only reason why I'm not calling it 1-propyne is because there's no such thing as 2-propyne. Because if it was starting on carbon number 2 and going to carbon 3, then we'd be counting in the opposite direction to give it still the lowest number of 1. So that redundancy we would avoid. So again, in case you don't understand what I mean by that, is if you saw something that was, and I'll draw it more in an angular manner here, like this would not be called 2-propyne because once you see the triple bond, you'd be numbering in that opposite direction. It'd still be 1-propyne, which again, just drop the 1 because it's not necessary. Second one, remember E comes before M. So I have to label the ethyl group first. The prefix di, because there's two methyls, does not play a role in the alphabetical order arrangement of subgroups. So 5-ethyl, 2,6-dimethyl, 3-heptine. When it's a triple bond, there's only one more thing that comes off of it. So even though that second one was drawn in a zigzag, it only has one thing coming off it. Unlike double bonds that have two things coming off of it. So there is no up and down, even though we kind of draw it that way. So anything that you draw a line angle kind of lends itself to saying trans when you just zigzag back and forth. But again, triple bond only actually has one more thing coming off of it.
Does it matter, like, when you're naming it, what you put first, like, in terms of, like, methyl or ethyl?
Ethyl has to come first. Yep, alphabetical order. Ethyl comes before methyl.
Oh, I thought it was numerical.
Okay, so that covers all the stuff that I will be showing you. Alkanes, alkenes, alkynes. Again, we did do cyclos already. Cyclo blank ane if it's all single bonded. Cyclo blank ene if there was a double bond within it. I wanted to remind you of something that was cyclo that we worked with back in the bonding unit, which was a benzene ring. Remember, a benzene is every other double bond, although technically it's not every other double bond. It was that idea of it's a blending of these different things that we can't really name properly. But benzene rings are a very common thing for you to see within organic chemistry as well. In fact, you just put a little Br right here and you have yourself bromobenzene. I mean, there's naming that you could do with that as well that we just won't be getting into. But really, that's it for notes.